Hey, my name's Mike. I'm one of the LaunchCode mentors. I want to tell you guys about how to do test-driven development today. So if you're doing unit testing your code, which you should be because it gives you awesome feedback and great insight into how your code works, you want to be doing it in a methodology called test-driven development, or sometimes called test-first development. So the main premise behind test-driven development is that you actually write your unit tests before you write your actual code. And what this does is it has a significant impact on how your code works because you have to write your code to be easy to test. If you've noticed, like all the principles of clean code, all the design principles, they're all geared towards making your code more testable. And so these two things are synonymous. Having clean code and being able to write good tests. And often your tests are a great barometer of how clean your code is. So let's get started. Here we're going to be replicating the CS50 project greedy, where we simply are given an amount of change and we have to return the fewest number of coins possible to represent that change. Now typically when we've been writing these applications, we've been putting all of the logic in the main method. Now this is fine, but however, if we want to use unit testing, we have to be able to write this so it's testable. And there may be a way, but right now there's no real easy way to call our Java program 100 different times with different input. We need a way to abstract it out. And so what we're going to do is we're going to employ dependency injection, and we're going to create a simple class where we can test it using Java and not have to call the Java program over and over. We can test it using JUnit, the de facto unit testing library of Java. So how about we go ahead, and I've made a class called CoinCalculator. And of course this class would be up in Spring because it does appear to be a singleton, but we're going to just do it this way right now just to get it done fast. Alright, so now we have the interface on CoinCalculator, and we have to decide at this point what our next step is going to be. So we've got this CoinCalculator. This is nice because now we can write JUnit tests against CoinCalculator instead of having to write it against the main greedy program. And we'll simply be able to return whatever the CoinCalculator asserts. So, given that, let's go into CoinCalculator, and in fact, if you press Control-Shift-T, IntelliJ will prompt you to create a new test. You can just say create a new test. Typically tests end with the word test, and we're going to use JUnit 4. Now the way JUnit 4 works is that there's a special test runner integrated into most IDEs, and what it simply does is it looks for any method annotated with @test, and these annotations, they're just ways to provide additional information about any method that you have. So any method annotated with @test, well, let's just say Alt-Enter, import, we're going to go ahead and run that as a unit test. Remember, unit tests run independently almost as if they're their own program. So let's write our first test, and it should be something like and so here you'll notice we give the description of the test as the method name. And that's very important to give a very descriptive of, hey, here's your input, what happens, and then how is it returned. We'll also have a very specific structure for inside the unit test. So it's always going to be setup, action, assert. And let me demonstrate. So we're going to have a new coin calculator, Okay, that's the setup, right? Because we have to create the coin calculator. Now, notice that we don't have a method yet defined on coin calculator to do the calculation. And that's good, because part of test-driven development is creating your ideal interface to this code. And when I say interface, I don't mean like a Java interface. I mean like, what would be the best way to work with this? Make it easy on yourself right from the beginning. So perhaps we could say calculate change. Okay, that seems like a good name. And what should we take? How about we just take the string at the moment? That makes it really, really easy. Because now, here, we can just say that calculate change var args 0. Wow, that's really easy change right there. Really easy code. And next we're going to say assert equals, and you know this has to return something, so let's have it return a string. And we'll just make it called coin message. Okay. So now remember, we can do Alt-Enter to do a static import, assert equals. And also remember, we can also do a Control-P within the actual method to see that, okay, the first one is what's expected to be, and then the second one is the actual. So we're expecting no coins returned to be the message. And then this is what is actually happening, the coin message that's getting calculated by calculate change. Alright, so you'll notice that we've typed out this entire unit test so far, and we still have this red. I specifically waited to create this method till the very end because it's best to write out the entire unit test and see how it looks, see how it feels before you commit to an API change. And when I say commit to a change, I simply mean create the method. Because there'll be inertia to go back and try and uncreate that method later, or try and create it again. So now that we've written the entire unit test, we know that it's clean, let's go ahead and create the method. And we're going to use the IntelliJ refactoring, and Eclipse has this as well. But just go ahead and press Alt-Enter. And you know, we're going to let IntelliJ create this method for us. And that's a pretty essential part of TDD, is that we're going to wait until the end to create this method, and then we're going to let IntelliJ do it for us. So Alt-Enter, create method, bam. It creates a method, it returns a string, it gets a string, and does nothing. Okay, second most important idea relating to TDD is that you always make your test fail first. And the reason for doing this is that you want to be sure that the code can actually fail. And believe me, I've written unit tests before where the test always passes, and it sounds like a great thing, but it's really masking any problems that could pop up. So the first thing we're going to do is we're going to compile and run the test failing. And this is compiling as we speak. Great, here's what we see. Alright, what we wanted to happen was to say no coins returned. We actually got a null. And if we click right here, that's going to take us to the exact test that failed. So let's go ahead and fix our code. And this is another important premise of TDD, is that we're going to fix it in the fastest, dirtiest way possible. And it's a little bit of a paradox because we always talk about TDD giving us clean code. Well, part of having clean code is having code that's not over-engineered. And so by fixing it the fastest way possible, even though I know that's not the correct solution, it allows me to work on one piece of the code at a time. And eventually evolve and have my code become new and better things. Great, I've got a green bar. Now, at this point, I would go back and refactor. I don't have much to refactor, so let's go ahead and create another unit test. Let's say 1 cent should give you 1 coin. Okay, nice. Let's say 1 penny instead. And you'll notice that I'm very specifically only writing these unit tests one at a time because we're only working on one thing at a time. Have a piece of paper by your computer and write down all the unit tests that you want to run beforehand. Only type them out one at a time. 1 penny. Now let's run this. And of course, we know this is going to fail because we're returning a hard-coded message. How can we make this pass? How about we say dot out of change dot length and -1, and then I can say integer dot parse Yeah, okay, so that gives us an integer with the amount of change, and now we can just put a simple if statement in. Say if change is greater than 0, return 1 penny. Else, return no coins returned. And so let's run this and try and see if it works. And notice this is not a very good change because I just wrote it really fast to get it done. This is not very clean, but it's good because I just wanted to get this thing to work. And great, it passed. Essentially, I'm just grabbing the last character of that string. I'm checking to see if it's a 0 or a 1 or not. And that makes it work. So great. Let's go ahead and write another test. And part of it is being oblivious to future tests that you have to write because we're only focusing on one thing right now. 10 cents should give you 1 dime. Let's run this again. We'll see it fail. And now how can we change this code to be legit? Well, what if we say dot substring being at index -2, that'll give us a string. We'll say integer dot parse, and I'll say else if change is greater than 9, then return 1 dime. And so hopefully this kind of demonstrates the process where you're just continuously evolving your code, making it get better Whoops, that did not work. Of course. That should work. So hopefully this demonstrates the process of continuously evolving your code, just continuously writing new tests and only focusing on the tests that you're doing at the moment. And this will provide you a barometer of how well your codes are in, as well as give you reassurance in the future that all of your code is working correctly.